Hello everyone, in this video I would like to show how to program a robot in Unity. In this time we make a pick and place sequence. Let's go. First of all, I place 2 new points for the start position and the finish position for pick and place. I use the robot panel for this, with which the tool's center point can be moved to the required position. For the target point, I choose the box in the corner of the palette. I make the small adjustments that grab point is located in center of the cube. I move robot 100 mm in height to avoid collisions between gripper and parts. Now I create new class for robot program. I delete standard methods and inherit this class from task class. I'll create a public list here, which we can use later for robot targets. Okay, good. Let's create new object and add the created task to it. Do not forget to insert reference to controller and target's positions. At the beginning, we make simple movements between 2 positions. I enable on the gizmos and compile a program. Now we can see a trajectory of movement. Let's start with this. Switch on the program and loop execution. Okay, fine. Now I create a temporary robot target to bring the position down. We can see this simple offset is 100 mm down to compare with previous target. I add the new linear movements with a wait instruction in between. That doesn't look correct. Index for position is wrong. Apply changes and compile a program. Now it looks good, but bring it back to the starting position. Compile and run program again. Okay, let's add some action. I create a new field for the gripper cylinder, which we use to control the gripper. I add the corresponding new action instruction to program. Do not forget to insert the reference. Now start again. Okay, awesome. I make gripper off at the end of the sequence. Good. Let's create movements for other cubes. The idea is that for the next cube we calculate the offset relative to the original position. In this case, the distance between the centers of the cubes is 75 millimeters. Now I put this into a for loop and calculate the offset with index factor. Looks correct. Let's test it. I'm going to define new references for frames and a method that we'll use later. I copy existing palette and add it as references to our program. I copy the loop content into a new method and refactor it. Now the idea is that we use this new method as a parameterizable subroutine where we can assign the corresponding reference frame and gripper signal. Apply changes and compile a program. Okay, good. The trajectories look correct. Let's run it and see the result. Let's add the reverse order of the sequence, so that the cubes are in the original position at the end of the program. Let's start the simulation and check the robot in motion. Let's do the bit interesting. I rotate a second reference frame and change order of place motions. This is a good example of the use of reference frames. When we change the position of a frame, all robot targets that correspond to that reference frame move with it. In this case, it is not necessary to adjust the robot targets and recalculate the offsets. It looks as expected. Let's start the simulation and check the final result. Now it's time for some optimization. When we compile a program, we can see the total movement time in the console. In this case, it's about 50 seconds. I add motion blending to the first point. With the fade, we can avoid deceleration and acceleration phases and save time. When I compile the program, the movement time is now about 33 seconds. You can also see the changes in the trajectory. Now the movement of the robot from the input point to the target position looks smooth. Such a blending is the most popular optimization technique in motion planning. In this case, we were able to save 16 seconds, which is about 30% of the total movement time. That's all for this time. Leave a comment and subscribe for more videos. Thanks you for watching.